Today we're looking at repowering the mini wood lathe with this washing machine motor. Welcome back to the mini workbench. We're today looking again at modifications to the Mark II mini wood lathe, and in this case we're looking at repowering. I recently turned up this V-belt pulley as an experiment with the intention of popping it in here and then utilizing our big old 150, I think it is, watt, maybe 140 watt washing machine motor, and putting that in and using that to belt drive. Now that looks like a massive motor for this, but I think it's going to be okay. It's got the torque. This one's at 180 watt, 10,000 revs per minute. This one that I've got here is basically 1440, maybe 1300 revs per minute at 140 watts, but about 1/5 of a horsepower. I need to increase the speed so that I've got a faster spindle speed, and so I've got this gear set up. This is from a site called blocklayer.com, and it allows you to put in some data and determine size of pulleys that we need. It actually works on the outer length of the belt, not the inner length. So normally belts like this automotive belt that I'm going to be using, if I can get it out of the box, I just happened to I've had this for a long time. At the time I bought it, it was the shortest belt I could find on the rack. I bought it for another purpose, but it's going to suit my purpose here quite well. I think there's only one smaller size. So this is an 11A, so 11 millimeters wide. It's an A shape, which is the particular profile of the V belt. And this is millimeters, 545 millimeters, but that is the inner length, from what I understand. But this tool, this site here, works on the outer length of the belt, so you have to actually determine the outer length of the belt. Now, what I did is I went onto eBay and I found different sellers of this particular part number, this belt size, and looked until I found one that actually described the outer belt, the inner and outer or effective belt length. So the belt length here is about 560 millimeters. I'm using I've experimentally just increased the diameter here to 115, and I've got 50 here. That gives me a ratio of, well, it doesn't say it on here, but 1300 revs becomes 3000 revs, so it's a bit over 2 to 1, or 1 point, actually it's 1.58 or something along those lines. It was written on the thing. This gives me centers of about 150 millimeters in full size, and a gap of 65. So it means that basically when I put that on there, I'll put that on that 50 millimeter or 2-inch wheel that I've got to make up here. I think this one was 60, so it's just a little bit smaller than that. So I'm going to make a new wheel pulley, and then the larger pulley on the other end, get rid of that, will mean that effectively, the motor will sit here over on this side, and I'll rewire the motor to the correct direction. I think it actually is running in the correct direction, but if I need to, I'll just rewire it. All right, so that's our little plan. A fifth of the horsepower, roughly 140 watts at 240 volts. It's nominally 1440 revs, but I think they turn out to be 1300 or 1350. So we should get about 3000 revs speed, which will be great for turning things from about 2 inches down. It'll be far too fast for anything that's larger, but I'm not going to be putting anything pretty much larger than this on this lathe. That's the biggest thing that I've ever turned on this little mini lathe. So this will be the update to version this which is version 2, repowering. It's got me, this bigger motor has got me thinking about really better layout, and and so a version 3. So version 3 is in my head, probably using pillow blocks, probably having the pulleys on the outside. That would make them easier to remove, change, adjust. Allow me to turn the motor around the other way to keep it compact, so the belt there, the motor here, and then the job here. The third thing is just a little bit more length, because at the moment, once I put a piece of timber in there, I can't really put something big enough to do a full size handle, like a chisel handle or something. So that's just a limitation of the current length. So maybe just a little bit more length, maybe another 100 mil to the overall length. So really making the next size up. So version 3 will be the next size up. It begs the question of shaft diameter. Now this is currently 10mm shaft, and my brain is going to 12mm shaft for the next one, but possibly I should go to 14mm. Then I can use some 14x2 thread. Not quite sure yet, that's things for the future, but a larger shaft, maybe 12mm. 12mm is a nice standard. In fact, the shaft on the motor is 12mm, so that gives me intercompatibility, I guess, with drive pulleys. Well, that's where we're heading. So what I'll do is I'll start to look. I've got a few things here. I've got a piece of Merbu decking board here, an offcut from down the street, a job that was done down the street. I've actually marked out, not sure whether you can see that, the 50mm and the 115mm circles. So cut those out on the bandsaw, put them on the well, it depends how well I cut them out, but I might put them on the sanding machine and get them close to diameter, and then we'll put them on the faceplate here, line them up. I've got a dimple there, so I can line it up using this to give me a center. That also then will become the center for drilling the hole. Well, here we are making dust again. I've just been turning up this 25mm radius, 50mm diameter, so thereabouts, or 2 bananas. This is obviously a pulley for this 11A belt, and we're getting a nice fit of that belt into there. I've actually done it a little bit, not sure whether you can see, but there's about 1mm's gap underneath the bottom of the belt once it's seated, which is just perfect. You don't want the bottom running on the hub. You just want to be seating in the V. So that's sitting nicely. So I'll just turn that around the correct way. Can just squeeze that in. So our belt's going to sit in there nicely. So I'm very, very, very happy with that. That little guy. Now this may be the last one I produce on here, because this is so much bigger. This is the 115mm. It's going to be a little bit less than 115, because that's already 114.5. So once I even this out, let's have a look at this dimension. Yeah, it's 150. All right, it's going to be near 115. But I will try it on here, but it's just a little bit large and it's a little bit scary. This guy might be able to do it. We'll give it a go, but I've got a feeling I might need to actually mount this onto the motor body and make up a temporary jig for making this groove. So this may well be the last pulley we ever make on this machine. I did use the tailstock to push a center in here, so that when it's actually, so I've got a center mark on this side, which is perfectly aligned or concentric with the with what I've just cut. But essentially, I run this tool in firstly some little notches, and then I run it in, basically building a narrow groove, and then I slowly take slices off that edge to give me the dimension I need. And one of the ways I do test it is I run, and you'll see it's rubbed there, I run the lathe, let's just do it. You can see that's one of the problems with this lathe, it hasn't got a lot of torque. So running that in there gives me a nice shiny edge, clean section right across the whole width of the V belt, which is good, which means it's purchasing or touching pretty much all the way across. There's a little bit of a rub mark I see on one side, so I might just sand that and see whether I can get it. Well, that removed it, but as to whether it's fixed it is the next question. Look out. Yeah, you can see that's rubbing fairly high. So there must be a spot on that, a lip on that. So let's cut that back just a little bit. I don't want to overdo that, so let's run it again. Looks like I've taken most of it off. May still be a bit of a bump there. Right, try that again. I think I've just widened that up a little. There's still a bit of a mark there, but it's much broader, so I'm quite happy with that. I think I'm going to fiddle with that for hours and not really get much better than that. I'm just very, very happy with that. Alright, good. Well, I'll see what I can do with mounting this to the faceplate and having an attempt at cutting this one. I'm not so sure about this one. I just don't think this machine's got the power to be able to, for me to cut something at that distance from the spindle. Okay, power off, and let's take that off. Well, I'm just about to do some cleaning up. I've just finished making the second of these on this guy. Went pretty well. This V-belt sits in there beautifully. It was a bit of work to chisel in and pare that down. This little guy has a fair bit of chatter in it, so it makes it uncomfortable, and particularly running at high speeds. So, but we've got a great result, so I'm very happy with that. So onwards and upwards in terms of that, using these two new pulleys. Alright, well, we've turned up these wheels, and I was just putting it on the bench here just to measure, because this little setup here said centres of 147 with this belt, and so if I tighten that on, put my thumb in there, not quite, rotate it a little, put my thumb in there, I think that's pretty square, it's close. So let's see if we can measure the centres between there and there. My goodness, I'm sitting on 140, let's tighten it, 146 maybe, if I pull it tighter, 140, 146, 147, centre's 147, can't go wrong. So the diameter was 114, this was meant to be 115, so I'm a millimetre out there. The diameter of this one is meant to be 50, and it's right on 50. So very, very happy with what's turned out with these V-belt pulleys turned up on the mini lathe version 2. On the mini workbench here, we've got the mini wood lathe. We're looking at repowering it. Originally it had this washing machine motor, and originally it had this sewing machine motor, which operates at, you can see there, 10,000 revs per minute, and that says, how many watts does that say? That says 180 watts, 10,000 revs per minute. We have a 150 watt, I believe, washing machine motor, that operates, it's an induction motor and operates at 1440 revs per minute. And I've done some work on calculating the reduction using a program, in fact using a website. It told me what ratio to use, 140 watt, which is half a horsepower. It told me what ratio to use for me to get that speed up to a more reasonable speed for turning. And so I've made those pulleys. I actually turned these pulleys on the mini wood lathe prior to pulling it apart, prior to removing the original motor. So I'm actually very pleased with them. I made them out of some leftover Merbau decking boards because I have some of that left over. And essentially what we're doing here now is creating a motor mount and positioning that motor mount just using those wedges. Positioning it before I tie it all together onto that board underneath. The board, that mini wood lathe, is mounted to that particular board already. I've got an excess one here because it overhangs. I need to sort that out. And of course I've propped it up at this end and I haven't shaped that up yet. But essentially the mini wood lathe is going to be powered by this washing machine motor with a reduction, with a with an increase to get the speed back up to a usable speed. Now, one thing I did mention in the last video is the spindle chattering. So this spindle chattering, and I actually found the issue. It was in here. The thrust bearing that I'd mentioned that's inside here had actually dried out, and probably because I didn't lubricate it when I put it together, just too busy putting it together, and it actually wore it wore the shaft out to the point where the shaft was actually loose at that end and wobbling inside the thrust bearing. So there's a step on the end of the shaft that goes into the hole in the middle of the thrust bearing. So what I have done is I've reassured myself there's no major drama here. I've reassured myself that I can use this spindle or this shaft, and so I've gone ahead and taken the plunge, disassembled it after cutting these pulleys, and started to put the thing back together. So that's the progress. I might do a little bit more work and come back and show you it running. That's the objective of this video, to get to the point of actually running this. Now, whether or not that is with that motor mount complete, or whether it's just me deciding that it's actually solid enough and I'll put some power on it, and I'm actually kind of close to that position right now. So let's see if we can add some power to this and get this thing running at the speed that I hope it will run at to be effective for turning small jobs. Well, there it is running. A little bit noisy. A little bit of run out on that wheel. Let's put our drive running here nicely. It's only a small lathe. With my hands down across there. Running pretty smoothly. Again, that wheel there is a little bit out. I'm a little bit disappointed with that. I thought I'd had that nicely turned, and I think I do. I think I've just moved that hole a bit crooked. So we'll look at that a little bit later. This end's running beautifully. So I think there's the capacitor. Actually being pretty careful with the wiring here. I'm pretty happy with that so far. So that's given me an encouragement to move on to the next stage and tidy this thing up. I think we'll leave it there for this video, but there's progress here with the mini lathe and the repowering, so I'm very encouraged. And I'll finish off the motor mount, then we might do a close-up of how I've attached the motor. Need to obviously make the wiring all safe, mount the capacitor. But I'm reasonably happy so far with the idea of repowering this. I think I've got the spindle speed that I need, so I'm very happy so far with the repower on the mini lathe. So as progress keeps coming along, I'll probably make another one or two more videos about this this lathe, if it's successful. If it's not successful, this thing might disappear off the channel. I'm pretty happy with it so far. It's a very simple little lathe. Anyway, thanks for watching.